Okay, so here we're going to continue on our verifying identities. We're going to do 3 examples here, just kind of each varying levels of difficulty, I think. So let's start with the first one, right? So the first one, all right, so again, the prompt is going to be verify the identity, right? Verify the identity. All right, and the identity is going to be cosecant theta, excuse me. So cosecant theta times cosine theta times tangent theta is equal to 1. All right, so again, the first step when working through a problem like this, approach it like, here again, I like to just write the little, is this equal, right? That's up to us. We want to verify that this is in fact equal. And then just draw yourself a line right there, right? Just to remind yourself that you don't want to move things from one side of the equation to the other. All right, now the next step is, well, how do I begin, right? So looking at this, 1 was just a number, right? So there's not much I can do with that. But here, so I'm going to start with the left side, right? I'm going to work on the left side and see if I can manipulate that so that when I simplify it, I get a result of 1, right? Now, again, I don't see any identities that I can apply right away. So the next step would be, well, let me just turn everything into a sine and cosine by using reciprocal or quotient identities, right? So cosecant can be written as 1 over sine of theta. Cosine, no, that's just cosine of theta, right? Just to avoid confusion, here, let's write it as a fraction just so, keep things as, we know what the denominators are, which ones are the numerators. And then tangent can be rewritten as sine of theta over cosine theta. Oh, and now we could see here, right? We can see, all right, if we multiply this out, right, we can approach it 2 different ways. We could see multiplying this out, we get cosine theta, right? Denominators times denominators, numerators times numerators, all right? 1 times anything is just itself, right? So sine theta times 1 is 1, and we get sine theta times cosine theta. All right, and now we could see here cosine over cosine is 1, sine theta over sine theta is 1, and we get 1. So we do in fact get 1 does in fact equal to 1. And that is it, right? That verifies it, right? Once you've done your manipulation and you get the same thing on the left as you do on the right, then we are done, right? We have verified the identity. All right, let's try another one here. So now how about, let's say, again, same goal here, verify identity. So you have cotangent theta over cosecant theta is equal to cosine of theta. Okay, all right, and again, I'll start off, are these in fact equal? And then draw myself just a line there down the middle. Excuse me here. So again, it's up to us to really choose what side to work with. The more complicated one here looks like the one that's on the left, right? And now the next thing is, well, what do I do, right? Notice that the right is a cosine, right? But on the left, I just have cotangents and cosecant. Now I really just have the fundamental identities at my disposal. So the only thing I have left is to just change everything into sines and cosines, right? Now be careful here, as things can get tricky when we have complex fractions. So cotangent of theta is cosine theta over sine theta. And cosecant of theta is 1 over sine theta. Okay, so I have a complex fraction, right? So in order to, so I would not like a complex fraction essentially, right? So how do I simplify a complex fraction? Well, it's the numerator, so you can change it to a multiplication is how you simplify it, right? So we take the numerator, cosine theta over sine theta, and you multiply it, right? So it becomes a multiplication by the reciprocal in the denominator. So by sine theta over 1. Right. All right. So now we got something going, right? We could see here that I can reduce those factors of sine. They reduce to 1, and we're left with cosine of theta over 1, which is simply just cosine of theta. Excuse me. And we are done, right? We have now established that the left side is in fact cosine of theta. Right, and that is it, right? Once you are there, you have answered the question, right? Verified it, I have verified it. All right, let's try one more here. So our next one here, we have cosine x minus cosine cubed x equals to cosine of x and sine squared of x. Okay, right, and again, goal is to verify the identity, right? So again, as a reminder, right, so I don't get the idea to move things from one side to the other, right? That is not what we want to do here, right? We want to stick to working on one side of the equation, of the equal sign. Excuse me. Okay. So looking at this here, they both seem kind of complicated here, right? There's not really, there's not one where I would say one looks easier to work with over the other one. Right? So what I'm going to do here is, well, I'm going to work on the left side here, right? Just kind of a hunch here, right? I'm kind of already seeing what I can do here, right? As opposed to the one on the right, which actually you could work with it as well, right? But looking at that, the one that kind of pops out to me is the one on the left. That being, the reason being is I have cosine and cosine cubed, so they have a factor of cosine in common. So I'm going to treat it like I would an algebraic expression where I can actually just factor it out, right? So I have cosine of x, and what's left here, if I factor out, there's only one factor here, so there is a 1 left, right? Not a 0, right? There's a 1 there. And here I have cosine squared x. Okay. All right, now here we're getting somewhere, right? I have a factor of cosine here, and I have one here. All right. Now the only thing that I have here is 1 minus cosine squared x, where I would really like sine squared of x. But kind of thinking here now, I was like, well, wait a minute. This is the Pythagorean identity, right? That's somewhere here, right? Recall that the Pythagorean identity, and here, let me work to the side here. The Pythagorean identity is sine squared x plus cosine squared x is equal to 1, right? Now this is true, right? This is an identity, so it's an equality, so I can treat it like an equation, right? And what I can do here is any variation where I can subtract cosine squared x from both sides, and I get sine squared x equals to 1 minus cosine squared x, right? So this is an alternative form of my Pythagorean identity, right? Once we know it's an identity, right? It is true, it's a fact. I can rearrange it how I want. And now I can see how I'm going to solve the rest of this problem. I can use these two quantities interchangeably. So if I have 1 minus cosine squared x, I just established that that is sine squared of x. All right, and now we have the same thing here, right? There we go, cosine x times sine squared x. All right. And that verifies the identity.